College Algebra Exam 2 review. All right, so this is going to reference the previous question. Use the leading coefficient test to determine the behavior of the graph of the given polynomial function. So the behavior. Technically, the behavior is kind of on the right side, right? So we'd be interested on to the right up over here and to the right down, these previous two. That's what they mean. And you can look at the behavior of both of these from left to right as well. Okay, so let's do the same thing. Okay, so in this one right here, it says 3 is positive. That's positive 3, positive. And 4 is even. Okay, well, what can we expect? Let's scroll back up a little bit. To the right, we notice that if it's positive, they're going to be going up, and because it's even, they're both facing the same direction, so both up. Okay, so now, this is more than they're actually asking for. I'm just being thorough, right? So the left is also up, because they're both up. To the right is up. Right? So the end behavior is usually this one right here, which is to the right up. It's going up towards the right, right? Okay. So let's look at this one. Okay, so what's the coefficient? It's negative. Okay, we need to look at that. Negative. And what power is it? It is third, so it is odd. It's an odd power. Okay, so negative odd power. Let's scroll up and look what that looks like, okay? Now we're looking at the left. So if it's negative and it's an odd power, it's going to be going down. From left to right, it's going down. Okay, so what we would say is if you go to the left, I guess if you wanted to be thorough about it, they didn't really ask for this, but it would be going up. But as you go to the right, which they are kind of asking because they're asking for the end behavior, it's going to be going down, down, just like that. Okay. So we want to find the intercepts and find the symmetry. If it has one, state whether zeros cross the x-axis or touches the x-axis and turns around at each zero. So let's break this down and just do the most basic parts of this first. So we're going to find the intercepts, and the intercepts are, we're doing it the same way we did the previous one. I'm going to try to do it maybe a little over here, give it a little more room. So to find the x-intercepts, just like before, we're going to set y equal to 0. I might not have enough room to do this right. So we have 0 is equal to x to the third plus 2x to the second minus x minus 2. Okay, so let's say we want to factor that. Okay, so there are 4 terms here, so I'm going to factor by grouping. So I factor something out of the first 2, factor something out of the second 2. Hopefully that's not too small for you to view. You might want to pause and zoom in. That might be too small. Okay, so out of x cubed plus 2x squared, I can factor out of an x squared, which gives me x plus 2. And then I can factor a negative out because I want to factor this leading coefficient, that negative out right there. Right? And I'm going to factor a basically equivalent of a negative 1 out. And that leaves me an x, not minus 2, but plus 2. Now notice that the x plus 2's match. So I'm going to factor the x plus 2 out, and that leaves me x squared minus 1. We're not done. We can still factor further. So the first part's okay, but x squared minus 1 is the same as x plus 1 times x minus 1. All right, so still trying to find the intercept right here, specifically the x-intercept. Now I would set every one of these equal to 0. All right, so minus 2, minus 2. I'm trying not to skip steps, but feel free to skip some of these steps, obviously. Then we have x plus 1 equals 0, minus 1, cancel, cancel. X is equal to negative 1, because we're just flipping signs here, right? X minus 1 is equal to 0, plus 1, cancel, cancel. X is equal to positive 1. All right, so we were able to find 3 x-intercepts. We're not done. We need to write these as ordered pairs, though. So we have a negative 2, 0. We have a negative 1, 0. And we have a positive 1, 0. Okay, so we were able to find 3 different x-intercepts. Okay, now we want to find the y-intercepts. I think I'll have that for. Okay, so y-intercepts, which means I set x equal to 0. So I would say f of 0 is equal to 0 cubed plus 2 times 0 squared minus 0 minus 2. I'm just going to be quick about these. These are all going to cancel out. The zeros are going to go away, right? 0 cubed 0, 2 times 0 squared is 0, 0 times 2 is 0, minus 0, so it's just whatever's left over, which is negative 2. So we just end up with a negative 2. Okay, so that means when x is equal to 0, y is equal to negative 2. And that is my y-intercept. Okay, so I have 3 x-intercepts and 1 y-intercept. Okay, so now we're going to find the symmetry. So first test let's do is y-axis symmetry. Where we plug in a negative x and we should get back the original equation. Okay. So what we do here is we do f of negative x, and hopefully we get back the original equation. Now I want to point out that since you do have some odd exponents here, right, that this is not going to work, because as soon as I start plugging in negatives into an odd, it's going to spit out a negative instead of the original. So since I do have these odd exponents, I know this is not going to work. So I will plug them in, but it should verify what I just said. Hopefully that makes sense. So again, I'm plugging in negatives, and since I don't, if they all had even powers, it would spit out the original. But since some of them are odd, it's not going to spit out the original, unfortunately. So this is not going to work. Okay, so we say negative x cubed is negative x cubed plus 2 times negative x squared is x squared. Subtracting negative x is the same as adding x and negative 2. And as we see, we did not, in fact, get back the original equation, so this does not have y-axis symmetry. Okay, so let's instead try x-axis symmetry, where we're going to be plugging in basically a negative y. Okay, so if I get back the, take the original one, and I plug in a negative y, basically, you know, that, would I in fact get back the original equation? And no, I'm not going to get back the original equation because of this, right? Now, if I plug in that negative y there, about the only way that's going to really give me back my original equation is if somehow I had some even power there, right? Because if I have an even power there for the y, it's going to allow me to flip things back over and turn that back into a positive, and I might be able to get back my original, right? But in this case, that is not going to work. So this does fail the test. There's no way I can do a simple algebraic manipulation, just multiply or divide both sides by a negative and get back the original equation. So it failed that one. Well, what about origin symmetry? Origin symmetry. Okay, so represent this with this. There we go. And so this one right here, if I did a similar representation, it would look like, whoops, it would look like this, right? That's where you kind of plug in, right? That's what I did. And then over here I did that. Okay, with origin, basically I'm kind of doing both, right? So I'm doing both a negative x and a negative y. And see if I get back the original, right? And I can already tell you that's not going to work, right? So we say f of, we have a negative x, well, let me put a y there instead. Okay. So let's say we have a negative y is equal to, and then basically the rest is going to look like what we did the test over there. So we're going to have negative x to the third plus 2 times negative x to the second minus negative x minus 2, which gives me negative x to the third plus 2 times x squared, which is positive x squared, minus a negative, which is the same as plus x, and minus 2. And so we end up with a negative y is equal to that. Now, even if I want to get this this side equal to y, right? A plain old vanilla y to get it equal to the original, right? Because that's what I want. So I'm simply going to divide everything by a negative 1. Or just flip all the signs, just the equal. So that gives you y is equal to positive x cubed minus 2x squared minus x plus 2. So even though I solved this for y, I was not able to get back the original equation, right? So this also failed. So it fails at symmetry, no symmetry, right? I do want to point out again, you can kind of tell where this is going to go based upon the powers, okay? So, and whether we deal with even, odd, those kind of things, but it didn't really ask about that. I don't want to go too far beyond what it's asking, but basically as far as symmetry goes, you can tell when I plugged in those negative x's, because I had some of these odd powers, it wasn't going to spit out the original. If it had every one of these as even powers, it would have spit back the original, and then we would have had y-axis symmetry here. As far as x-axis symmetry, this would have worked a lot better if we would have had an even power over here on the y. Then when we plugged a negative y in, it would have sped back with the original, right? So that's kind of a hint on how to do x-axis symmetry, or just plug it in, memorize and plug it in. That works. Origin symmetry, basically both of the other ones. Whether it has to do with whether they're odd. That's one way you can think of this. So they're all odd power. You have y is equal to, and then you have 3 1 or 5 3 1, stuff like that. Also, there's other ways for origin symmetry as well, but that's, you can kind of start thinking in terms of the exponents, and a lot of times they'll tell you whether they're even or odd, or whether they're well, they will tell you whether they're even or odd, but they'll tell you the symmetry of them.